Okay, we'll go ahead and get started. This is Julianne with ProSoft, and I want to thank you all for joining this webinar, Your Guide to DNP3 Distributed Network Protocol. So before we start, I want to do a little housekeeping. So during our session, you'll have a chance to ask a question in the Q&A panel. Just go ahead and put that in there and we'll get to those at the end. Also, we will share the presentation with you along with a copy of the recording afterwards, so look for that. All right, so I'm going to go ahead and introduce Vishal Prakash. He is our product manager for several industrial protocols and remote connectivity platform and IoT solutions. So with that, take it away, Vishal.
Thank you, Julianne. Good afternoon, everyone, and thank you for your time today. I trust that all of you guys are keeping safe and healthy along with your families. As Julianne said, my name is Vishal Prakash. I've been with ProSoft for just under 3 years, but I've been in the industry for over 20 years with a lot of my background in the utilities side. So whether it's water, wastewater, oil and gas, power, and even broadcast. Okay. So before we get started, so for those of you who don't know who ProSoft is, we were founded in 1988 and we are headquartered in California. So we've been around for 30 plus years. And our focus is really on protocol translation, protocol conversion, and getting that data once it's converted from A to B safely and securely through a variety of wireless communication means. And that includes 802.11 and also cellular wireless communications as well. ProSoft is a global organization. It's part of the Belden group of companies. And ProSoft has got regional offices in the EMEA and the APAC region with well over 100 employees. And we sell into 60 different countries, all around the globe. We're pretty well known for our product support. So I just wanted to highlight that. One thing to keep in mind is all of our products do come with free support. And it's not just product support, but our support team has got significant application experience in a variety of automation platforms. So they're really able to delve into the issue and help you solve it. Now, before we get started, we're going to start off with a poll question. And the poll question that should be appearing shortly is, do any of you know about DNP3 protocol? And if you have you used it? So if you could please get some of your answers in, just give it a few more seconds. Okay. So we have an interesting mix. So it looks like, we have actually quite a high percentage who've heard about it. So that's really, really good. And then we've also got some that have actually used the protocol as well, which is actually excellent. So today's session is all about DNP3. So for those of you who didn't know, the idea is that by the end of today, you've got a very good idea of what DNP3, the basics is, and really how it can help you if you're in the utilities, or if you're a systems integrator that you talk to customers in the utility space, how it can help you obtain reliable data from very remote sites, so that where the information is stored locally and then up to the top end, ensuring no data loss. So based on that, our agenda is fairly simple. We're going to be looking at the basics of DNP3, the key features, and what the customer benefits of those features are, and then, of course, the conclusion. Okay, sorry, so just give me 1 second. Okay, so like I said, DNP3 is primarily used in the utilities, where the automation systems for these utilities are always remote. And we also know that utilities really is the very fabric of life. Without these basic services, we will not have the mega cities that we have today, just all around the world. We would not have the explosion in the urbanization and also the population growth that's centered around these mega cities. Really, none of this would not happen if it wasn't for these essential utilities. And the other thing to remember is that utilities is always a continuous service. So with that being said, they do face a number of issues, but they're not limited to things like aging infrastructure, lack of funding, and of course, increased regulations, including security as well. We won't be able to solve all of those problems. What we are looking at today with the solution that we're talking, which is DNP3, is how we can help utilities overcome data reliability and data integrity issues. Next slide. So data integrity, that can be defined as the accuracy and validity of the stored data over its life cycle. And reliability is the consistency of the measure of that data that's being recorded. And according to sort of one of the reports that I've seen from the EPA, they indicate that approximately 20% of the data they get from, in this case, the water utilities, is really deemed unreliable. So data reliability sort of is a real issue for a lot of the utilities, and the impact of that data reliability or the unreliable data can be pretty severe. It impacts everything from regulatory reporting all the way through to funding, maintenance, and the end result of all of this unreliable data, if you've got that in the system, is it can lead to sort of lower efficiencies of the operation of the entire utility. And a lower efficiency means you've got a lower level of service in terms of the end customer, which obviously none of us want. We all want, when we flick the switch for the lights to turn on, we all want to make sure that when we turn on the tap, there's water flowing. So to get to that point, they really need to address this, this very significant unreliable data problem. Here's another question, and I can promise you that this is the last of the poll questions for quite some time, and it's more of a trivia question. It is about, do you know how many public water utilities, water authorities there are there in the U.S.? So there's some range of answers. Again, if I can please request you to enter that in, that would be awesome. Let's give it a couple more seconds. Okay, so we've sort of got a mixed bag of answers. Approximately 30. So the highest number, the vote was for anywhere between 50 and 60,000 water authorities. Believe it or not, we've actually got over 120,000 public water systems here in the United States alone. And that's not excluding some of the other utilities. So apart from the 120,000 plus freshwater, drinking water utilities, we've got over 16,000 wastewater utilities. We've got over 300 power systems, power authorities, and over 1,000 local gas distribution authorities or systems that really make up the utilities. And this is just in North America. If you take many of the other countries, it's pretty significant. So the point of this trivia really is to show how many utilities there are and the opportunities that is there for the solution to be adopted. Okay, very good. All right, so many of the solutions to address this data reliability issues today is a bit like these potholed roads. You have to use them, and then it'll get you where you want to go, albeit with some broken bones and some missing parts. So the solution is not very nice, but it is something that you'll have to go through again and again. And if you avoid, the problem just becomes worse, where you're not resolving, you're simply putting it away. The solution, the path that we're going to take is something about that has no holes. And in this case, the holes is in reference to the data that's coming from the utilities. It should be smooth sailing because a lot of it is recorded. It's secure, and it's also future-proof. It's something that ensures long-term reliability of these utilities and the availability of these utility services for the customers that depend on it. So this solution, as you saw from the heading of the title, is DNP3. But the path to the solution is actually two. Step one, to address this reliability and this integrity, we're going to be looking at DNP3, which is an open protocol, which is a secure protocol, and it addresses a lot of the accuracy issues. And step 2 that we're going to really touch upon towards the very end, because that's a topic unto itself, is about the connectivity. Because if you can have all of this reliable data, and if you don't have the connectivity, it still does not meet its purpose. The entire idea is to bring back all of the data from these remote sites, which is obviously the common factor that binds all the utilities. All of their assets are geographically dispersed. So if you're not able to bring that data back in for analytics and for other purposes, then it defeats, it does not help with improving the efficiency of that utility. So the introduction, so DNP3, what does it stand for? DNP3 stands for Distributed Network Protocol. Like I said, it's primarily used in the utilities and primarily for telemetry communications. So that, because again, with utilities, you've got all of these assets that are geographically dispersed. You have to have communications to bring all of that data back through to your top end. In terms of history, DNP3 protocol was developed around sort of the late 80s. It was actually developed by a company called Westronix here in North America, in Canada, actually. And it has been an open standard since 1993, which is controlled by user groups. So it's sort of very vendor independent. It is the standard for North American power utilities. In fact, here in North America, over 90% of the power utilities use DNP3. It's a proven protocol globally. Many of the water authorities, other utilities in countries like Australia and the UK, certain parts of China and the Middle East, they've all adopted DNP3 as a standard for all of those features that I've listed. And we're going to go through each one of those features a little bit more in detail so you can understand why this feature was introduced, why this feature was incorporated into this DNP3 protocol, and what the customer benefits of these features are. So just a very quick look. Now, DNP3, obviously, like with any protocol, there's a fair bit to it. We won't have time to go through all of them, but what we will be looking at some of the more basics, so you can have an understanding as we talk through the features and you come across some of the technical terms. Started off with some of the more common DNP3 terms that you will hear. Again, we'll be sharing the slide with you, so you don't have to take down notes or copy this down. But out of all of this, for today's webinar, the key thing that you want to pay attention to is the class of data, which is the class 0, that is sort of all of your static real-time data, and then class 1, 2, 3, which is event or time-stamped. And again, we're going to go through that a bit more in detail. The other key term you want to remember out of this is the unsolicited response, where the outstation has the ability to send in data without being asked for it. And that sort of is a very, very important feature, which improves the efficiency of a utility system, and hence why DNP3 is very widely adopted. So I mentioned that the most important thing is the data type, the the class 0, which is a static data. So one of the nice things about DNP3, when you compare it to, let's say, a protocol like Modbus, which is very widely used and been around for a very long time, is that DNP3 allows you to not just classify your data, but also give it a class that designates it to either be a real-time data point or a time-stamped data point. And the time-stamping happens at the source, which again has got its own relevance that you will see in the coming slides. Excuse me. So with class 0 data, what it means is that when you do a poll or when it is sending that information from the remote site to the master, it only sends a real-time information. So the current value of all of the different objects, the tags that it's monitoring, that information is sent, so you can have a real-time view of what's happening on site. And then you have the class data, which is time-stamped based on the priority, that tells you more from a historical perspective what happened. So, if the level did fluctuate or if the pressure did change, but it was within range, you can still see that history. But it's not something that you would know of every single time there was a very small change in that particular pressure value. Excuse me. Okay. So let's look at the key benefits, the key features and the customer benefits of these features for utilities using DNP3 protocol. So the first key feature of DNP3 is that it's a protocol. It's an open protocol. There's a users group that guards the protocol. They're the protocol guardians. So this was a technical committee that was formed in 1995. They're completely vendor independent. The protocol itself has been open from inception. But really, a few years after the protocol was started, this technical committee was formed, and they've taken over to be the guardian. So it is completely vendor independent. And unlike Modbus, there is actually no variance of the protocol. And they achieve that through what's called as a compliance requirement through something called as the device profile document. So any product or any solution out there that's a DNP3 based solution, they have to create and release this device profile document is what it's called. And that lists all of the features that the product or the solution is compliant to. So by this way, what they do is rather than having variants of the same protocol, they're able to have the same set of standards, the same set of features, but give the vendors the independence or the ability to say that we only comply with a subset or certain number of features, and hence the different levels of compliance. So that's where the 3 comes in with DNP3, which right now it's up to level 3. And typically products and solutions can either be 1, 2, or 3 compliant. So if you look at the customer benefits of this open protocol, one of the biggest benefits is that you can now have a common top end, but then have the flexibility to have remote outstation hardware or software solutions that really fits in the application. So for example, you're not tied to using the same DNP3 product. Let's say, for example, at a smaller substation versus a much larger substation. You're able to scale as long as it complies to the functionality that you want. You can then pick and choose what product you want for each of your remote sites. The other advantage there, you don't have to have all of your eggs in one basket. And that allows the vendors to keep themselves honest, where you're not stuck with a particular vendor that's doing things like price gouging or is not able to support a type of function. You're always able to look outside, but still know that you can have a common top end where all of these remote sites can come in and you still have a very well-leveled utility monitoring system. One of the nice things about DNP3 is it also allows for easy expansion. It does support a very large number of remote assets, not just assets, but also objects, which is like a tag within this. If you're monitoring a variable or point, that's called an object. It does support up to 65,000 objects. It gives you this expansion, which fits in nicely for some of the larger utilities out there. So the next feature that we want to talk about is timestamp. To me, this is one of the most critical. It's also known as the event-based or event log data. And any object, and remember, an object is just a tag, it's just a variable, a point that you're monitoring. It could be an analog object, it could be a digital, which is called a binary object in the DNP3 world. Any one of those objects can be configured with a class 1, 2, or 3. That's the timestamp part, where it will be timestamped when there is a change in that object, whether it's a change of state, whether it's a change of value, or over a period of time, but it is timestamped and stored locally. And I think the big advantage there is, especially if you're in an area where you've got, let's say, unreliable communications, then you don't want to lose data because you've lost communications. And with DNP3, that does not happen because you've got all of these events that can be stored. And remember, you can get access to the real-time data anytime you want, right? So you can get that back and you still have a current or an accurate overview of what's happening to your system. But with the timestamp data, it gives you that very historical perspective of what's really happening, which is very, very useful for a number of different reasons. Okay, so the customer benefits, and as you can see from the trend, the picture on the right-hand side, you would not have any holes in your data. So here's an example of a trend. You've got some device that's providing data, and let's say if you've lost communications over a period of time, if you're using Modbus, you typically will not get any data during that period, and that would show up on your trend because you would see sort of exactly as you see here a fat line. But with DNP3, because of the ability to timestamp and store the data, it could still capture those events, store it in its memory, and then when communication recovers, you can get all that data back to your top end where you can backfill your trends and so forth. So certainly no holes in your data. And the other benefit, because you've got accurate data, it helps with reporting. As I indicated earlier on, utilities today are subjected, they're highly regulated in terms of how they monitor their system, how they control their system, how they operate their system, and then also regulations in terms of what data has to be recorded, stored, and reported back to the various authorities, whether it's the EPA, whether it's the Energy Commission, whatever it is. So by having this timestamp data, you're able to provide very accurate reporting. Another big customer benefit of having this timestamp data is predictive maintenance. So if you think about an asset that's there at a remote site, if you don't have very accurate information of how long that asset has been operational, then you cannot do the maintenance on it to extend the life of that asset. So again, having that critical timestamp data is very, very important. And the fourth benefit is root cause analysis. So here again, if there's an issue on site and you're trying to resolve to make sure it does not happen again, you won't be able to perform the root cause analysis to really get to what caused the failure, the issue, without having that accurate data. So really for all of these reasons, sort of timestamp data is absolutely critical, which is why I think that this is one of the most important features and benefits of this DNP3 protocol. The next feature is unsolicited reporting. So here we are talking about the ability for a remote site. And remember, with utilities, all of their assets are geographically dispersed, right? So nothing is local, other than if you're talking, let's say, about like a treatment plant where you've got several processes, like chlorination and sedimentation or clarification. They're within a very huge plant. But other than that, almost all of the assets are geographically dispersed, whether it's substations, whether it is offtake stations in a gas distribution system, they're not all at one location. So the ability to have all of these remote sites initiate a message to the master and send data is critical, because what it really does is it increases the efficiency of the entire system. Imagine having a system where you always have to go in a circle and you're polling all of these remote sites continuously, which is the way SCADA systems used to work. The disadvantage with that was, as these systems grew and they got bigger and bigger, sometimes that ability to go and just ask everyone to say, give me your data, could take several minutes. And during that time, if there was an event, if there was an emergency, you would not know about that till you got around to polling that site the next time. And the disadvantage with that is, as I said, if it's an emergency, you've got this time delay before you can react and before you can look at resolving the issue. So from that perspective, unsolicited reporting really increases the efficiency of the system. It enables you to prioritize the communications for your entire system to make sure that you can get back the most critical data quickly. And then because you associate the unsolicited reporting along with the timestamp data allows you to store normal events, things that you would consider normal, it would be timestamped and stored locally that you can then bring back, let's say, at a different frequency to ensure that you've got maximum bandwidth available to bring back all of the alarm data. So if you look at the customer benefits of unsolicited reporting, two primary benefits. The first one is instant alarm notification or alert notification. And of course, like I said, the increased communications efficiency. Okay. Now, the next feature we want to talk about is data classification. So each of these features are kind of intertwined. What we've gone through, they're all interconnected. With data classification, again, related to the timestamping, where every event you've got date and a timestamp, the classification, what it allows you to do is, especially these automation systems, and they're fairly complex. You take a substation today, you take a gas distribution and offtake station, or you take a major pump station. These are quite complex pieces of automations that manage these systems. And there is a lot of data that comes out of this, data, real-time operational data, you've got diagnostic data, um, you've got historical data. So you've got a lot of data from these sites. And without this classification process, you would be forced to bring all of this data back to the top end all the time. Again, that does not help with the efficiency, because now you're clogging your bandwidth, bringing back what could be a normal event that you still want to know about it, but you don't need to know about it straight away. With classification, you can now say, okay, this particular event, or something changing state, or something just simply logging how long it's been running for, is normal. I don't need to know that data straight away, but you can log that data and then, let's say, bring that back every 6 hours, every twice a day, whatever it is. And the advantage of all of that is you can get alarm data, instant notification of all of your alarm paths, alarm information that would allow you to react quickly, let's say when there's an emergency on site. These data classes, they are independent of each other. So, where you've got 4 classes, 0, which is real-time data, and then 1, 2, and 3, that's timestamped. They're all independent of each other, which allows you to bring only a certain type or a certain class of data during a particular communication sequence. So the customer benefits, the user's got complete control over the configuration. Again, like I said, you're not in a position where you have to configure all of your, for example, your digital I/O to be one type. You don't have to do that. You can say, certain types of digital I/O, while I want to know the status, they're not as critical as, let's say, a fault indication. And so you can give a fault indication a class 1, and you can say something, a different type of digital input could be sort of a class 3. It also allows you to select what information needs to be timestamped and at what frequency or what conditions. So again, you don't have to timestamp all of the data if you don't need to. You can then decide on the frequency as to when this data can be sent. Said, once a day, every 6 hours, depending on what it is, which the idea being that you want to keep your bandwidth as free as possible to ensure that you can get alarm information, or in real world, sort of the emergency, if there's an emergency on site, you want to know about that straight away. So by keeping that bandwidth clear, you're able to achieve that. This is a really cool feature, select before operate. With DNP3 protocol, one of the nice things that it allows you to send sort of before you turn something. Today's control systems, they do monitoring and control, which has obviously also changed as communications have become more reliable. But at the same time, you also want, if you want to turn on something, or if you want to trip a transformer, you want to switch the voltage, whatever it is, you want to be sure that the action that you're initiating is actually going to happen, and you can get not just feedback, but before you actually execute the action, you want to make sure that everything is right on site. So with the select before operate feature, what DNP3 allows you to do is to basically send in sort of a pre-command to say, are you available? And if it receives a positive response, then it would go ahead and execute the action. And that could be, like I said, changing voltage, tripping, could be turning on a pump, could be turning off a pump. But with any of those actions, the precursor is to make sure that that I/O point is available before we can actually execute on it. So the advantage, I think, the customer benefit of select before operate is it vastly reduces the risk of unintended actions, like operating something by accident. And the control action also can be timestamped. So, if you've got the right class, remember I said that all of these features are intertwined. So now you can have a control action in the select before operate that can be timestamped, which then gives you that traceability when you're executing that action which is, again, very, very important if you're trying to do root cause analysis or you're trying to understand what's happening inside. Okay. So just a reminder, as I am going through, if you've got any questions, please feel free to use the Q&A window to send in your questions, and we should have enough time to get through them towards the very end. Now, this next feature I want to talk about is secure authentication. So this is based on the IEEE 1815-2010 standard. And also with secure authentication, you've got to have the top end that also supports the same level of secure authentication for this to be effective. What I wanted to start off with is to give you the difference between encryption and authentication. Encryption is something that we hear about a lot today, where I say, all of the data is encrypted, and that is very, very important. Encryption means, where the meaningful data is sort of garbled, and it cannot be understood until it can be decrypted. Authentication, on the other hand, is more about convincing the other party to say who you are, that who you say you are. And the advantage of authentication, especially with DNP3 secure authentication, is that it would work on any network. You don't need, encryption typically works on an IP-based network, right? With authentication, it could work on any network. If you've got frequency hopping spectrum radius for communications, or you've got a serial-based radio network, authentication would work on any type of communications infrastructure. So the advantage there is you're able to at least increase the security of your utility system without having to immediately change all of the communications infrastructure, which can be a pretty expensive exercise to undertake. So the way secure authentication works is you've got a SCADA master, and let's say you've got a slave. That could be a gateway, could be the PLC that you're talking to. And let's say the SCADA master would say, here's a command to turn on an output. The output could be, like I said, anything. Could be turning on a pump, could be switching the position of a valve. The slave would then say, okay, I've got the command, and it wants to verify to say, how do I know who you are? So I've received this command, but I want verification that it's being sent to me from the right source, the right address, all of those things before I can actually execute on it. So it goes back and says, I've got the command, I know who you are, but why don't you tell me who you are? Once it's received that verification, then it is able to execute on that output through to the end action, which is, turning on the pump or changing the position of the valve and so forth. So going through that additional process, that additional step to verify that the command was right before it can execute is very, very useful and obviously secure as well. So here's some information just on some of the acronyms that you will hear from a security. Security is big. Remember that the security threats are always persistent. So security has to be something that's continuous for utilities. And you've got different kinds of standards. You've got various things that, if you're a power utility, you have to be NERC CIP compliant. That's starting to come in. You've got the Department of Homeland Security that can walk into a utility and ask them to see if they're secure and do some testing. So you've got some standards from NIST, which is the National Institute of Standards and Technology, and then also the NERC CIP compliance. But the key takeaway from all of this, and security, can be a mind-boggling topic. There's a lot to it. It's a very, very important topic. But the key takeaway is that, between the NERC and the CIP requirement and all of these, the solution, the DNP3 with secure authentication is going to help with that compliance. So it is a pretty significant feature and something that will help you get covered with those requirements. Okay, so the next feature we want to talk about is time synchronization. So again, DNP3 has got support for time synchronization at the protocol level. Again, that's something that's important because a lot of the legacy protocols don't support time sync. And the reason why it's important, we've already spoken about why having that reliable and that accurate data from a remote location is extremely useful and important for things like root cause analysis and predictive maintenance and regulatory reporting and so forth. So, now you've got all the data, but if it's not accurate in terms of the time, then again, it does not help with solving some of those issues. And the nice thing with DNP3 is it supports that at a protocol level, so you don't need, an additional device, or you don't need additional logic to create that. You can handle it at the protocol level as well. And with DNP3, both the master can send in that time sync command, so on a regular basis to make sure the remote sites are all time sync. But at the same time, a remote site can also request to say, just make sure that my clock is synced, so all of my logs are accurate to the right time and so forth. The customer benefits of time synchronization. If you take today, about one of the biggest costs for many of the utilities is the amount of energy it takes to run many of the assets. You're talking high powered pumps or valves that consume a lot of current. So by having this accurate time synchronization, you can then plan and schedule the operation of some of assets where you can then save energy, which obviously helps reduce your operating costs. And then, of course, as I've already previously mentioned, having that accurate data is going to help you with things like predictive maintenance modeling, and then also reporting as well. Okay. So I've spoken a lot. We're actually going to go through, it's time for another poll question before we go through to the next section of this webinar. So you've got two questions here that's come up. The first one is, have you ever heard of ProSoft's persistent data network to connect remote sites, or PDN? And also the second question is, if you are a utility customer, or if you know of utility customers, do you know what type of communications that you either use or know that they're using to connect all of the remote sites? So again, if I can get those responses in, I would really appreciate it. Okay, so thank you all for your responses. So it looks like quite a few have actually not heard about ProSoft's PDN solution. So we will certainly, I'm going to talk about it very, very briefly, but like I said, that's a topic unto itself. We will, get in touch so you can learn more about it. The other poll question that we got, it looks like a large number of respondents responded saying that frequency hopping spectrum radio is probably the most popular of the communication means to remote sites. So again, thank you for your responses. Remember at the very start, I mentioned that to address the data reliability and the data integrity issues for utilities where all of their assets are remotely geographically dispersed, the solution is going to be in two steps. The first part was the DNP3 with all of its features where it addresses that reliability issue. The second part is, now that you've addressed that and you've got the accurate data, you want to bring that back on to the master. And that's where ProSoft's PDN, or persistent data network, comes into play. This is an always-on cloud-based infrastructure network that today can use either cellular or wired devices to connect your remote assets. This is truly, I've been in the industry for over 20 years, and this is absolutely fantastic. It is super simple. I'm very excited with this solution from ProSoft. It really is the most simplest and the most secure way to connect remote sites. Some key advantages of this solution is, one, it's completely carrier agnostic. As you can see from the picture, this is a little demo system that we have where we got sites all around the world that can connect and communicate. They're all on different cellular carriers, and they can all talk to each other on a single network. That's key. That's something that you don't get with sort of carrier-based communication networks, because they're tied to a specific carrier. And let's say if you've got an area where they don't have good cellular coverage, you don't have means of monitoring, or you got to put in a secondary system to monitor those few sites. With PDN, you could have sites on different carriers and they can all come together. And the other key feature of this always-on connectivity is continuous security. Remember, again, I said that security threats are persistent. We've just seen what's happened recently with another water utility. So security has to be continuous, and that's what PDN offers. So just very quickly, to address the reliability, the data reliability, and the integrity issues with remote sites, especially with utilities, the recommendation is to use DNP3, and then also to have this always on the secure connectivity, bring all of that data, because now that you've addressed where you've got the accurate data, you want to make sure that you've got access to all of the data to ensure that the system is running smoothly, very efficiently, without issues. Okay, so we're coming to the very last slide before we can get to the questions. So in summary, utility is a critical infrastructure where the assets are geographically dispersed and it's highly regulated, not to mention that they don't get as much funding as what they would like. But one of the main issues that utilities face today is data reliability and integrity, and we can solve that issue for them by using DNP3 protocol for all of the features that we spoke about. If you use DNP3, it does ensure that there's no holes in the data, which then the benefits of that ranges everything from regulatory reporting through to better predictive maintenance, through to better root cause analysis. Some of the other benefits of using DNP3 is to make sure that you've got these alarm conditions. And that's because of the unsolicited reporting ability, where you can have remote sites that have the ability to initiate a message to send in any alarm information rather than waiting for it to be just pulled as per normal you would in the older systems. Secure authentication, which works on any type of communication network, is another very important feature of DNP3. The timestamping at the source is absolutely critical because you don't have this delay as to where some event might happen. It may only be just a few seconds or a couple of minutes late, but that still has an impact on things like predictive maintenance and root cause analysis. So timestamping at the source is very, very important. And then finally, with the select before operate, you have the ability to reduce the risk of any unintended actions like turning on something which, turning on a pump, it just sounds like, oh, you're just turning on something, but that could have some pretty significant consequences, such as things like affecting another process, or if you've got somebody in person, where it cause damage not just to the machine, but also personnel as well. So having that ability to verify the action before you can actually turn it on is something that's very, very important as well. Very good. So with that being said, I'm going to open it up for questions.
Okay. So it looks like there's a question coming in that says, can you see any movement from DNP3 to IEC 61850? Will it occur?
That's an excellent question. So IEC 61850 is a newer protocol than DNP3. And again, the power utilities are behind that push of trying to adopt that protocol. They're very similar in a lot of ways between these two protocols. I do think there will be a push for the IEC 61850, but if you look at how many solutions and how many people are using that, it's certainly not as high as DNP3. Over a period of time, I do expect that there will be combinations of DNP3 and IEC 61850 based systems, but the IEC 61850 will certainly be something that the power industry is going to be using more commonly, let's say, compared to many of the other utilities.
Okay. Another one says, is it correct to say there is DNP3 serial or Ethernet? I think is what he meant to say. Do you see that one?
That's correct, yes. So DNP3 does support serial and Ethernet, two different versions. And yes, the solution from ProSoft will support both of those options on a single module.
Very good. Okay. I see another one. Will DNP3 protocol work over a serial radio link?
Yes, it worked. Yes. The fact that, like I said, DNP3 supports both Ethernet and serial, it will work, if you've got a serial-based radio system, or you got serial-based frequency hopping spectrum radios, it will still work any of those serial links as well. Yes.
All right. I have one on predictive maintenance. Can you explain how DNP3 helps with that?
That's a very good question. So if you think about predictive maintenance, there are different types of maintenance, right? You can do maintenance after the effect, you can do based on just gut reaction. But predictive maintenance is really about having the data before you can go ahead and do the work. And predictive maintenance is all about extending or maximizing the life of the asset, which, some of these assets are pretty significant in cost. So you want to make sure that they are operated as per manufacturer's recommendations, and you're doing all of the servicing and all of that to ensure that you get the maximum life out of this asset. With DNP3's ability to timestamp data, and this is just not real time, so it's just not status data, but you can have operational data. If you're monitoring things like, for example, the number of times an asset has started or how long it has been running for, an asset could be operational at a remote site for several hours during the day, but there could be start and stop. So if you're able to trap all of that information, timestamp it, and then if you're bringing all of that back into your top end, where you've got a very accurate record of all of the events on the site with the data and the timestamp, you're then able to use that information to do better predictive maintenance modeling. So if you're sending out somebody to do scheduled maintenance, you now have the data backed, you have the data with you to ensure that you're doing it the right way. So that's where the DNP3 helps with predictive maintenance modeling.
Very good. Another one, how about a USB serial connection with newer Allen Bradley processor?
A good question. So the solution from ProSoft will support direct USB connectivity to the Rockwell platform, the Control Logics and the Compact Logics platform.
Mm-hmm. Okay. All right. Give it a little time for some more questions. While I'm waiting, I should mention when you close out your webinar, there will be a survey. It will be in your browser. So if you guys could do that survey, that'd be awesome. We would appreciate that.
Yes, thank you for that reminder, Julianne. So please do fill out the survey, because it helps us improve in the topics that we're presenting to you, the content, the format, to make sure that, when you give us an hour of your very valuable time, we want to make sure that it is as effective as possible. So we really would appreciate if you could take the time out to fill out those. Thank you.
Absolutely. Yes. All right. Maybe I'll close it out then if we have no more questions. Oh, we got one coming in. What tools do you offer to help design a DNP network? DNP net.
Okay, so I'm assuming that it means that it's a DNP3 communications network is what tools you ask. I mean, okay, good. I guess the very first question or the very first comment is, what would be the communications media you're using? So if you're using, let's say, wireless communications, and let's say it's 802.11, we've got a designer that can help you with that. If it is cellular-based communications, one of the beauties about cellular communications is that you actually don't need to do a lot of preliminary work. There is no things as radio surveys and so forth. So that reduces the time that you need to spend in designing a communications network by significant amounts. So we can help you with that as well. I mean, all you need is to check if there's cellular coverage, and you'll be good to go. But if you're using wireless, yes, ProSoft has got a wireless designer tool that can help you design a communication system. If you contact us through our support channels or your local regional sales manager, we can certainly help you with that.
Okay. All right, very good. This has been a great webinar. A lot of good questions and a lot of good information. Thank you again, Vishal, and thanks everybody for joining. Thank you also for filling out that survey. Thanks in advance. And we'll go ahead and close it out.
Thank you all. Thank you all very much for your time. So look forward for a link about the webinar, the recording of the webinar, which will also include the slides as well. Again, any questions, please either contact your local distributor or your regional sales manager.
All right. Have a good rest of your day.
Thank you all.